Right then, hello. As promised, here is a video about the timer. In brief, the video camera filmed the circuit diagram. Let's take a closer look at the circuit diagram. Zooming. I hope the circuit diagram is clearly visible and understandable. I start from left to right. We have the battery that supplies the voltage for the button. Button A1 works like a doorbell. Therefore, no switch may be used in this position. It mustn't have a hook function like a switch. On the top, two 24-volt light bulbs connected in parallel. A little further down and to the right, switch C3. Switch C3 is optional. Down, switch B2. This switch should be used in the circuit. Last but not least, the power source, 5 to 36 volts. In this demonstration, 24 voltage DC is applied. This is the state of technology at the moment. Here we have two sources of energy, a test board with two protective diodes, current input for the button and power input for board and switches B2 and C3. A 24 volt light bulb, each at the top right and left. Okay, let's zoom in. In the next step, a program or a program number should be activated. Switch B2 on. The preset program will flash 3 times. In this case, it is program P4. The program P1.1 is to be activated. Press set for 3 seconds. Program P4 lights up. Select the desired program number by using the up or down buttons. Once the desired program number has been selected, press set for 3 seconds. The display flashes 3 times and program 1.1 is visible. After the flashes, the display will show the standard view. Program 1.1 is saved. To check, repeat by pressing set for 3 seconds. Now program 1.1 should be displayed. To get back to standard view, press set for 3 seconds. The display flashes 3 times and program 1.1 is visible. After the flashes, the display now shows standard view. This procedure can be used for all program numbers. Next step. Setting up the relay operations OP, CL and loop. Program number P1.2 will be used as an example and the OP mode will be edited. The display shows the standard view. Press the set button for 3 seconds. Now the program P1.2 is visible on the display screen. Press set briefly and the display will flash 3 times in OP mode. Once the flashing has stopped, the display changes to the current OP value, in this case 17 seconds. I change the time value from 17 to 5 seconds. For the next steps, I prefer the chapter on sheet 12, setting the time dimensions. At the moment, the decimal point is at the bottom right next to the 5. That's 5 seconds. Press the stop button briefly and the decimal point moves 1 decimal position to the left to the value 0.5. That is 5/10 of a second, or rather a half second. That's 5 minutes. That's 5 seconds again. That's a second and a half. That's 15 minutes. That's 15 seconds. And at the end again 5 seconds. Now back to the chapter Setting the Relay Operations, sheet 4. If the value 5 seconds is set, press the Set button for 3 seconds. Next, the display will flash 3 times and P1.2 will now be displayed. Once the flashing has finished, the standard view will be visible on the display. The OP value 5 seconds has been saved. You can check the OP value by pressing the Set button briefly. First off, the display will show the OP mode and then show the 5-second value. Once you've checked this, the display reverts to standard view. This procedure can be used for all programs with OP and CL values. Next step. Mode CL will be edited. Program number P2 will be used as an example. The procedure is almost identical to the one just shown. The only difference is that program P2 requires a CL value. The display shows standard view. Press Set for 3 seconds. Now P2 is visible on the display screen. Press Set and the display flashes 3 times in OP mode. After the flashing has finished, the display changes to the current OP value, for example 5 seconds. This can be kept or discarded as the CL value will be edited. Press Set again briefly and the display flashes 3 times in CL mode. Once the flashing has finished, the display changes to the current CL value, for example 13 seconds. Set the desired value, for example 20 seconds, using the up and down buttons. Once 20 seconds has been selected, press Set for 3 seconds. Next, the display will flashes 3 times and program P2 is visible. The function of the time dimensions and all other procedures correspondent to the previous step. Once the flashing has finished, the display will show standard view. Now CL value of 20 seconds is saved. You can check on the OP and CL values by pressing the Set button briefly. The display shows the OP mode first and then 5 seconds. Next, the display shows the CL mode and its value of 20 seconds. Once you've done your check, the display reverts to standard view. This procedure can be used with programs P2, P3.1 and P3.2. Next step. The mode is to be edited. P3.1 is used as an example. The display shows standard view. Press Set for 3 seconds. Program number P3.1 is visible on the display. Press Set briefly and the display flashes 3 times in OP mode. After the flashing has finished, the display changes to the current OP value, for example 5 seconds. This can be kept or discarded as the loop value will be edited. Press Set again briefly and the display will flashes 3 times in CL mode. Once the flashing has finished, the display changed to the current CL value, for example 20 seconds. This can be kept or discarded as the loop value will be edited. Press Set button briefly again and the display will flash 3 times in loop mode. Once the flashing has stopped, the display will show the current loop value, for example 13 cycles. Set to the desired loop value by pressing the up and down buttons, for example 9 cycles. By the way, for loop mode, apart from setting 1 to 999, setting 3 short lines is also possible. This setting means infinite cycles. This setting is only possible from 000 downwards. To change from 999 to 3 short lines is not possible. A change from 999 upwards starts again at 000. So much for that. If 9 cycles have been selected, press the Set button for 3 seconds. The display next flashes 3 times and program number 3.1 is visible. Once the flashing is over, the standard view is visible on the display. Now loop value 9 cycles is saved. The OP, CL and loop values which have been saved can be checked by briefly pressing the Set button. The display changes to OP mode and 5 seconds appears on the display. Then the display shows the CL mode and its value of 20 seconds. Then the display shows loop mode and its value of 9 cycles. Once you've done your checks, the display changes to standard view. This procedure can be used for program numbers P3.1 and P3.2. Next step, operating mode for each program. What happens after pressing button A1? Which functions run in the timer? Before starting, switch C3 must be switched on. Okay, let's go for it. I start with P1.1. A standard OP value of 12 seconds is specified. Pressing the push button A1 starts the timer. The relay opens for the duration of the set OP value. The timer counts up from 000 to the set value. If the external button A1 is pressed or held down again during the process, that won't have any effect on the timer. The relay closes once the programmed OP value is reached. The display reverts to the standard view. Next step, program P1.2. A standard OP value of 12 seconds is specified. Pressing the push button A1 starts the timer. The relay opens for the duration of the set OP value. The timer counts up from 000 to the set value. If the button A1 is pressed or held down again during the process, the timer goes back to 000 and starts to count from 000 up again. The relay remains open. The relay closes once the programmed OP value is reached. The display reverts to the standard view. Next step, program P1.3. A standard OP value of 12 seconds is specified. Pressing the button A1 starts the timer. The relay opens for the duration of the set OP value. The timer counts up from 000 to the set value. If the button A1 is pressed briefly or continuously during the process will be stopped before it is completed. The relay closes. The display reverts to the standard view. Next step, program P4. A standard OP value of 12 seconds is specified. Pressing the push button A1 starts the timer. The relay opens for the duration of the set OP value. The timer counts up from 000 to the set value. If the button A1 is pressed briefly or during the process, the timer reverts to 000, but the relay remains open. The timer counts up from 000. Keeping the push button A1 pressed down keeps the timer at 000. Only after releasing the push button A1 does the timer count up again from 000. Once the set OP value is reached, the relay closes. The display reverts to the standard view. Next step, program P2. Program P2 works in reverse as a switch-on delay. A standard OP and CL value of 4 seconds is specified. I'll check the values again. OP 4, CL 4, OK, checked. Pressing the button A1 starts the timer. No light bulbs lights up. The relay remains closed for the duration of the set CL value. Once the set CL value is reached, the module changes to the OP mode. The relay opens for the duration of the set OP value. Both light bulbs lights up. During the expiry of the set CL and OP times, no further signals can be given by pressing the button A1. Once the OP sequence is complete, the relay closes. The display reverts to the standard view. Next step, program P3.1. A standard OP and CL value of 4 seconds is specified. 3 cycles are specified for the loop value. I'll check the values again. OP 4, CL 4, loop 3, OK, checked. Pressing the button A1 starts the timer. The timer counts up from 000 to the set OP value. Once the set CL value is reached, the sequences begin again according to the number of set cycles. Once the OP value is reached, the module switches to the CL mode. The relay closes and the light is off. If push button A1 is pressed again during the set CL or OP sequences, they will stop before they are completed. The display reverts to the standard view. Next step, program P3.2. The program P3.2 does the same processes as P3.1. However, it's started without the button A1. The start is triggered exceptionally with switch B2. A standard OP and CL value of 4 seconds is specified. 3 cycles are specified for the loop value. Switch B2 on. The display flashes 3 times. The timer counts up from 000 to the set OP value. Once the OP value is reached, the module switches to CL mode. Once the set CL value is reached, the sequences begin again according to the number of the set cycles. Once the value of the set cycles is reached, the relay closes. The display reverts to the standard view. Now something about the interaction of the button A1 with the program P3.2. To start program P3.2 again, the switch B2 must be returned to the off position. The program P3.2 is started again with switch B2. The display flashes 3 times. The timer counts up from 000 to the set OP value. First off, if the button A1 is briefly pressed after the operations have been expired, the module immediately switches to off mode. The display is off, even if switch B2 is on. Secondly, to restart the program P3.2, the process of the last step is repeated. Switch B2 must return to the off position. The program P3.2 is started again with switch B2. The timer works through the processes. If the button A1 is briefly pressed during the process, this has no effect in the operating mode. But after the operations are over, the module will immediately switch to off mode. The display is off, even if switch B2 is on. And now to the special topic, the addition units of time. If the time settings are different, for example OP 15 seconds and CL 2 minutes, then the module cannot add the values accurately. The mathematical process is not really logical, but you can understand it. In other words, you can also say crazy. I'll say upfront. The timer takes the 2 minutes as the total time and subtracts the 15 seconds from it. That means the light bulbs are light up for 15 seconds. After 1 minute and 45 seconds they are off. Then the next phase begins, and after 15 seconds the light bulbs light up again. This results in a total time of 2 minutes. You can bin the first phase. It's all out. Okay, let's go for it. I am also starting the timer with a stopwatch. Right, I'm shutting up now and will let you listen to Mark's guitar. The clock counts up to 15 seconds and the light bulbs should be off. Okay, that's fine. Oops! After 32 seconds, 1 minute has already gone by. As I said before, bin the first phase. We can't wait to see what else happens. Oops! After 1 minute and 32 seconds the light bulbs light up. Everything a little crazy. But the first phase is done and now the times are right. I'm resetting the stopwatch and measuring again. After 1 minute and 45 seconds the lights should light up. It's okay that the timer is showing 1 minute after 45 seconds. It subtracts 15 seconds. Now it's all up in the air. At 1 minute 45 seconds the light bulbs should light up. Okay, that's fine. The next light show should then start at 3 minutes and 45 seconds. Okay, that's fine. Okay, now it's time for a break. The next question is, what happens when OP is 75 seconds and CL is 1 minute? The timer must then subtract 75 seconds from 1 minute. The values then go negative. Okay, let's go for it. I start the timer with a stopwatch and we will witness the show. Complete mess. Okay, I make a break here. All very strange. We can still play a bit and generate flashing lights for parties, Christmas or birthdays. Of course, you can also generate high-speed flashing lights. There's still a lot to tell about the timer, but I think that's enough. I've linked a user's manual that anyone can download. So take care and see you next time.